I think the example 2 on the next page, 222, is really a similar one. We have a graph of the derivative, okay? They're not asking us to analyze this graph. They're asking us to look at this graph to figure out what the original graph is doing. Remember, this is all based on theorem 1 on this page. If the derivative is positive, we know the function is increasing. If the derivative is negative, then we know the function is decreasing, okay? So on this, I'm going to get a highlighter and mark the section of this graph, mark like this much in red, and say this is above the x-axis. The red part is above the x-axis, which means f prime is positive, right? Well, that tells us that f must be increasing on this interval. Well, from what number to what number? From -2 to +6. So you'll say this original function must be increasing on -2 to 6 because its derivative is above the x-axis, aka positive. Okay? Now, there are two pieces of this graph that is below the x-axis. This one right there, that's below the x-axis, and that one right there, that's also below the x-axis. So below the x-axis means the original function f must be decreasing. And this is to the left of -2, agreed? This is to the left of -2. So you will write that as -infinity to -2. And this section right there, this one starts at 6, right? But goes on. So decreasing again from 6 to +infinity. And the positive infinity indicates that this function will go on forever to the right in the negatives, okay? So let's write our answers down. Decreasing on -infinity to -2 and 6 to infinity. And it was increasing on -2 to 6 because the piece of the graph was sticking above the x-axis. So let us sketch a graph of this, okay? So the special points, if you look at our numbers, okay? The special points are at -2 and 6. So you just mark those. Here's my -2. Here's my +6. Okay. To the left of -6, remember we said the function is decreasing. So I'm going to sketch a graph that is going down to -2. And I'll plot a point here. This is where we have to stop for a second. Stop right there. Because what will happen now is from this -2 to +6, what did we say? The graph is going up. So I'm going to sketch a graph that is going up to +6, but I'll have to put a dot here. But it's not going up to the right of 6. It's going back down to the right side of 6, right? So sketch a graph that's going down forever. So I can just put some arrow tips like this, okay? And here is a graph of, possible graph of f. As long as I can mark, I marked my critical points at -2 and 6, okay? My relative minimum and relative maximum at 6. Doesn't matter how high up or low this is, because any function that looks like this could have a derivative that looks like this, okay? All right, so let's answer some of these questions here. Where is the relative minimum happening? Where's the lower point? Where's the low point right there? And relative minimum is where the function changes from decreasing to increasing, okay? So that's where it is. So I'll say the relative minimum is at -2. The relative maximum is where the graph was going up and it stopped and going right to the, going down to the right from that point. And that is going to be 6 right there. So that's the max and that's the minimum, okay? And that was the example on page 122. Really similar to the first one that we did, but it looks like, this section, because we had two pieces of arm going below the x-axis, the original function had two intervals where it was decreasing.